when you find something. Okay, good morning, welcome to my student. Good morning, students. This is the chemistry class, chapter 2, state of matter. I didn't his, so actually it is state of matter. Okay, you know these things, everything in the universe. I shared you about this. Everything in the universe, all substance are two types, two things. Everything around us, one is matter, another is energy. Matter has mass, matter has mass, and energy has no mass. Matter, like which are matter, so, everything which has mass and occupy space is called matter. So can you say which one is no energy, which are which things are not matter? Like you take gas is a matter because it has mass. Gas is a mass. Liquid, water, oil, everything you take this you weigh, you'll find mass. So water also matter. Can you say which thing has no mass? Light energy, magnetic energy, all energy has no mass. So everything is around us is two part. One thing is matter, another thing is energy. Okay. Today's topic is state of matter. Chapter 2 is the state of matter. We know state of matter, there are three state of matter. Look, this is the state of matter. This is the H2O, water. Water when in ice, it is solid state. Water when liquid, drinking water, it is liquid. Water when it start to boil, it is the gaseous state. So three state of matter: solid, liquid, gas. You know these things: solid, liquid, gas. Look, all matter exists in one of three state: solid, liquids, and gaseous. Each of these have different arrangement of particles. Like solid particles, liquid particles, gas particles. Solid particle rigid, liquid not rigid, gas not rigid. Solid has fixed shape, fixed volume, fixed shape, fixed volume. Liquid no fixed shape but fixed volume. Gas not rigid, no fixed shape, no fixed volume. Cannot be squeezed. This can be squeezed, cannot be squeezed. Squashed, can be squashed. Those state of matter, state solid, liquid, gas. Solid are rigid, they have fixed shape and fixed volume. They have fixed liquid, they have fixed volume but not fixed shape. The gas have neither a fixed shape nor fixed volume. So arrangement particles in solid particles. Particles look solid particles. All particles are regular arrangement, and particles are close together each other. And particle movement, particles don't move apart. They only vibrate at a fixed position. This vibrate in a fixed position. And forces between particles, stronger forces than liquid, stronger forces. And shape, they have fixed shape and volume. This is the solid particles. And particles in liquid, irregular and close together each other, and move around. One particle move around, slide past one another. And forces between particles not as strong as solid. it is less strong forces than solid. Shape, no fixed shape take place a shape of container but fixed volume. They have no fixed shape but it takes the shape of a container. If you take a liquid in a round bottle, its shape will be round. If you take the in a rectangular shape container, shape will be liquid will be rectangular. So it takes the shape of the container, but it has no own fixed shape, but it fixed volume. They have fixed volume. They have volume, but it has no shape. It takes the shape of container. Okay, the particles arrangement is irregular, and particle in gas arrangement is irregular. Irregular arrangement, particles are far apart each other, and particle can move freely, and not force existed, and they have neither shape nor volume. So what is the shape? This look at this particle arrangement in solid state. Particles are regular arrangement. Look, pattern is regular, same pattern. So they have a stronger attraction force among the particles. Stronger attraction force among the particles. But here in a liquid, these particles shape are not regular. So irregular shape. Particles are some close together. Irregular shape. In a gaseous state, particles are irregular and far apart each other. This is the solid solid state. That's the okay, solid. This is the solid state. This is the liquid state. So okay, this is the liquid state, and this is the gaseous state. Okay, so now book, I give this book from these things. Your last exam performance is excellent. You have done excellent. All got almost 15, 14 like this. I checked, but all student result I didn't check. I give result today. By today, I published your result. Okay, solid. A solid matter has a specific mass, volume, and shape. A solid. Okay, all solid liquid has a mass. So solid matter has a specific mass, volume, and shape. Molecules of all matters have force of attraction. Okay, molecules of all matters have a force of attraction. For this reason, all particles close together This force is known as intermolecular attraction. This force is the most the intermolecular force attraction is most in the solid matter. As a result, molecules solid stay very close to each other in a fixed state and take a fixed dimension, and which cannot be compressed with pressure. Again, a solid matter hardly changes. Hardly means don't changes shape when temperature is raised. It changes shape, but when it becomes liquid. What is the characteristic solid? Solid has specific mass, volume, and shape. They have intermolecular forces. The force above is the most of in the solid. The intermolecular force of attraction is most in solid matter. For these reasons, solid are very close to each other, and they have fixed state, and they have a fixed dimension which cannot be compressed with pressure. Now liquid. This question may come from in objective multiple choice question. Now liquid have a specific mass, volume, but don't have a shape. Liquid take the shape of their container. Since the molecules of a liquid remain farther from each other than those of solids, the intermolecular force of attraction is also less than solid. So it is intermolecular force of attraction is less than solid. Such a matter don't change volume when force is projected or force is applied on them, but volume increases with rise of temperature. This change of volume is greater than that of solid. Now gases also have specific mass, but they don't have specific volume or shape. Whatever quantity of gas is put into any size of a container, it takes over the full size of that container. If you take any container, any gas, it takes the full size of that container. The molecules in gases are farther than those of liquid. It is far away molecules of liquids and solid. The intermolecular forces of attraction also very low among them. A small quantity of pressure is enough to compress gases, and is in the same way a small amount of temperature is enough to increase the volume of such matters. So what is the intermolecular force of attraction? Hello student, what is the intermolecular force of attraction? We know this particles contain due to the particles in a matter. We know there are many particles. These particles, due to a force, these particles close together. So there is a force among particles. The force among the particles of a molecule is called intermolecular force of attraction. Now we do the kinetic theory of particles. We have already known this. Every substance is made of small particles. Now topic is kinetic theory of particles. Every substance is made of small particles which remain together by means of intermolecular force of attraction. This every substance is made of small particles which remain together by means of an intermolecular force of attraction. These molecules also have a kinetic force in them. Due to the movement, particles have a force. This is called kinetic force. Okay, these molecules. So we have understood this small all substance made of small particles, and which remain together by a means of intermolecular force of attraction, and also another force, kinetic force. Okay, the attempts to prove the state of substance using intermolecular force of attraction and kinetic force of the particles is known as kinetic theory of particles. So what is kinetic theory of particles? Say someone. What is kinetic theory of particles? What is kinetic theory of particles? Say anyone. Excellent, excellent. Say another student. This is the attempt to prove state of substance using intermolecular force of attraction and kinetic force of the particle is known as the kinetic theory of particles. So what is the kinetic theory of particles? This one, here to here. When the particle inside a substance remain in a very high force of attraction, they stay together and cannot move that much. This is the solid state. When particles inside a substance remain in a very high force of attraction, they stay together and cannot move that much. This is the solid state. When heat is applied on such a solid substance, the particles start to vibrate. This is the solid substance, liquid substance, gaseous substance. Look, when more heat is applied, the particles lose some of their force of attraction. When more heat is applied, the particles lost some of their force of attraction, and they start some movement. This state of matter is called a liquid. Liquid takes the shape of the container without changing their volume. When more heat is applied on the liquid state of the substance, the particles receive the heat and kinetic force in them is increased. Kinetic force due to the movement. Kinetic force in them is increased. This kinetic force is increased to a level where they lost intermolecular forces of attraction almost completely and start to move freely. This is the gaseous state. When more heat is applied to this state of the substance, the particle will only increase their speed of movement. Okay, so this is the kinetic theory of particles. Look, this solid substance, these particles are close together because strongest attraction force among particles. This is the particles how particles start movements. So here attraction force is stronger, but less strong than solid, and there is a stronger there is no attraction force, almost no attraction force of attraction force among particles, so particles move freely, so it is the gaseous state. Okay, the diffusion. Okay, what is diffusion? Diffusion is if you take scent or attar, if you use scent in your cloth, this scent sweet smell spread throughout the room. This gas particle move throughout the room. Even your mother in a chicken room kitchen room can chicken room the kitchen room can find the sweet scent if you use scent in your bedroom or your dressing room or drawing room. So how this is possible? Because particle move from a high concentration region to lower concentration area. A high concentration region means where particles are more particles. A low concentration means where particle more concentration means where particles are more. A low concentration means low number of particles is less. So what is diffusion? So diffusion is not yet solid gas state. Diffusion also occur in a solid also gas, also liquid also diffusion occur. So movement of particles spontaneously. Do you know the spontaneously and uniformly from higher concentration region to lower concentration region is called diffusion. So the tendency of solid, liquid or gas to spread spontaneously or and uniformly in any medium is called diffusion. In diffusion process, solid, liquid or gas moves spontaneously from a place of higher concentration to lower concentration. So there is a so what can I do? No. This is a house. You use here a boy is this boy use scent here. This is the high concentration scent particles and this scent particles move throughout the room. This is the lower concentration area uniformly, like two particle, one particle, same uniformly and spontaneously. This is called diffusion. Spontaneously means automatically, spontaneously. Uniformly means same particles, like one particle, two particles, same particles move. So the tendency of solid, liquid or gas particles spreading from higher concentration to lower concentration is called diffusion. So the tendency of solid, liquid, gas to spread spontaneously and uniformly in any medium is called diffusion. In diffusion process, solid, liquid or gas move spontaneously from a place of higher concentration to lower concentration. Okay, the tendency of solid, liquid or gas to spread spontaneously and uniformly in any medium is called diffusion. In diffusion process, solid, liquid or gas move spontaneously from a place of higher container concentration to lower concentration. Remember, What happen if you leave a perfume bottle with its lid open in the corner of a room? Within some time you will find the whole room smelling of perfume. This is an instance of diffusion. This is an example of diffusion. If a matter takes lesser time to spread, its rate of diffusion is higher, and vice versa. It takes the more time, its diffusion rate is less, and if take the lesser time, diffusion rate is rate of diffusion is more, and this is the vice versa. Then now read through the following experiment. This is the this is experiment. We take diffusion occur not only in the solid, it also occur in the gas, not occur in the gas, but also occur solid and also gas. Now here is an experiment in liquid. At room temperature, you take pure water in a glass jar, add a small quantity of pink potassium permanganate. Potassium permanganate is color is pink. You take in a gas potassium permanganate into it. You will see after some time the potassium permanganate grains are dissolving into a pink solution. Indeed, the potassium particles are getting motion and scattering freely in the water. In this case, some solid matter is diffused in water or liquid. The rate of diffusion of solid matter in water is slow. However, if heat is applied, the rate will increase. Diffusion rate, if you take the diffusion rate in winter time, winter session, and summer time diffusion occur more because temperature, if increase temperature, diffusion increases. In the winter time temperature is low, so diffusion rate is low. So if similarly, if you do the experiment of diffusion of potassium permanganate in hot water, the water will turn into pink solution faster. In case of the potassium permanganate particle will get added motion due to heat and scatter faster. This shows that the presence of heat increases the rate of diffusion of solid. Okay, experiment 2. At room temperature, take some pure water in a beaker and add some liquid blue in it. Within a few moments, you will see that the water has turned blue. That means the particle of blue solution or some liquid have diffused in the water. The temperature being the same, it is taken the liquid less time to diffuse in another liquid than solid potassium permanganate. That means the rate of diffusion of liquid matter in another liquid is faster than in solid matter. The presence of heat will increase the rate. At room temperature, in the presence of heat, gaseous matter diffuse the fastest. The diffusion of liquid solution in liquid. So which substance is liquid? Solid substance diffusion rate is more, or liquid substance diffusion rate is more? Okay, that means rate of diffusion of liquid matter is in another liquid faster than in solid matter. If you take the solid matter in a water and liquid like potassium permanganate here, and here blue is liquid. If you take the same time, diffusion occur in a liquid is faster in blue color, because liquid diffusion is faster than solid, and also gas diffusion is fastest among liquid solid. Now experiment 2, diffusion. Okay, today's class here, these things I'll give you assignment in Google Classroom this evening. Thank you for joining today's class.